Okay, this is Team Texas Tech, Red Raiders.
Get your guns up.
You gotta be careful of that because it also looks like the loser side.
Yeah, no, we're not losing up. That's why I hold them this way.
Yeah, you gotta be careful about that. Okay. Okay, so this is all of you, right?
Yes, sir.
So,
well, and Nick, he likes to hide.
Nick, who's hiding, we're gonna get him in there. You know, you guys have had a hell of a road getting here. Your hardware didn't show up.
Exactly.
That's happened before.
Yes.
You were going to do something really cool. You're going to be the second team to do a whole immersion.
We did one.
Well, you did. Yeah, you got some stuff immersed.
Correct.
But this is like homegrown immersion.
Yes. We designed everything.
It was all done by hand.
That's pretty cool.
Yeah.
Let's take a look. Because I mean, when Texas did this, it was with a vendor that does immersion.
Yes.
So there was nothing. You know, it's not conventional, but they didn't have to put a lot together. You guys,
I mean,
this is all hand done.
We did a lot of test and mock over the year. I built a couple of little small systems to actually show that we could save on nodes, specifically to show energy and how much power we're saving, temperature testing, putting overall power consumption. So we did a lot into it.
Did you guys actually do your own fluid?
You
were talking about
I almost did. I actually have the next. I have a next grade up that's fully biodegradable.
Yeah.
The only problem is producing it on an industrial scale at Texas Tech is not possible. There's no.
Oh, put me as such a girl. Go out and get a factory.
True.
Yeah.
The thing
That's the next best thing, but it is considerably more expensive too because it's a lipid-based structure. So you actually use it's almost like a glycol. You actually add on another carbon onto the glycol chain, and it becomes a 4-carbon thiazole. And what you do from there is you use a lipid and you attach the lipids onto each part of the alcohol, and the backbone structure takes the properties of the lipid, melting point, boiling point, all those things.
So you're lowering the boiling point.
Yeah, so you can make a very strong structured lipid structure that doesn't conduct just electricity and is not flammable.
But you're lowering that boiling point, which is going to take the heat out.
Yes, and it actually allows us to pump it more efficiently. So you can tailor to the size of the chain and actually have it be a liquid below freezing temperatures of water. So you're not worried about it freezing, you're not worried about flammability, and now you're not worried about biodegradability because that's the next add-on to it.
And the whole thing is that you can pump it more easily with more commercially available pumps because the viscosity stays lower with the liquid that he was talking about.
We're only using
what are you guys using for a pump? Like
we're actually using a bilge pump from a boat. It's a 12-volt pump. Right here, this little thing.
That's it?
And it does 1,100 gallons per hour. For for the 800 gallons that we were originally going to use 0.28 amps on 120. Exactly.
0.28 amps.
Yeah, so
on 120 volts.
On 120 volts.
You take off on one of these U's. You take off 300 watts, and then you get more efficiency through electron motility.
Well, the thing is, as electronic circuits heat up, the electron motility in the transistors goes down, so each transistor dissipates more power. So you get a small power savings by keeping it at a lower level. Sure. And the other thing is that this
You're not running fans also.
So you take off, you get more efficiency, and you take off electricity from it. So you see about 300 to 350 watts of increase
per U on this node.
Per U.
Per U?
Yes. So each U is 300 because we tested these ones and we have these on.
H2U.
Yeah.
No.
But per U is 300.
It was a 2 kilowatt.
The fans in it were 0.5 a piece, each one, and there's 4.
At 12 volts.
At 12 volts on each U.
Well, then you're also taking off those CPU fans and that sort of heat.
The only thing you can't do is that we found out is that the power supply fans you either have to emulate them. Or exactly. So when the torque goes off, so that's the problem with the liquid. It'll stop the fans. So they don't have enough torque. Yeah. Okay. Well, we didn't want to do too much emulating on the fans.
I heard about your hillbilly fix on that.
Yeah.
Now, some guys would say we got to go in and hack the BIOS.
Well,
so
the thing
that's not going to do, but that's hard.
We tried hacking the BIOS, but it's a logic board. See, I'm computer engineering, and it's this logic board, and Dell never gave us access to the firmware on this logic board, or what these 6-pin connector does. Okay. Because I know what 4 pins do. There's one pulse width modulation connector, there's one 12-volt, one tachometer, and one ground.
So what we're talking about here is that if it doesn't see a fan on, it's not going to boot.
Exactly. Only on the power strip.
Because of the firmware.
Because of the firmware.
And we could not change the firmware and we didn't see. BIOS doesn't even deal with this. This is internal to a power supply.
Okay, even before the BIOS.
Exactly.
So what'd you do?
We shaved the fan fins.
We shaved the fins off the fans,
but
so it's
you
a
actually
rotating
see
barrel.
an increase in movement in the liquid too because of these. So these don't totally, they don't totally, but through the power is where a lot of heat is too. So you actually get a little bit more movement in your power source.
But that's a nice fix. That's a good pragmatic
cheap,
fix.
easy fix.
And the reason why it still flows is because of these channels. The friction of the barrel allows these channels to guide and suck the liquid through.
But and the key part is the system sees that the fan is on.
Exactly.
And it's working.
So you can honestly, if you have 4 or 5 of these power sources, you could honestly, if you could emulate the fans, you could power the pump and our radiator. So we have a radiator right here, and you really can't see it.
Yeah, I can see it.
Well, they're from the back. We have 2
You got a couple of fans there. It looks like
and 2 radiators.
Are those big case fans?
Yes, but they're some of the nicest on the market. Right?
What you didn't go ahead and go with, because it looks like you got the radiator out of a car. Looks like a
they're two thermal.
Is that a heating core?
Transmission oil.
Transmission oil radiator.
So we didn't go too far to say that. I mean, engineering a radiator doesn't make sense when all this does is you boot this on your car and it's already made for oil, right?
Yep.
So why don't we just run fans through it?
No reason why not.
Exactly. So we extended the size of the radiator also by putting a second one in and sandwiching the fans.
Okay, so you got one back behind. Okay.
Yeah, we have 2 fans. Pushing through.
Okay.
And these fans only use 0.07, and they do 166 CFM, which is high air movement, very high air movement.
And this is giving you enough heat dissipation to fill up that rack.
Easily enough. Correct. This was meant for all 4 nodes to be submerged.
Okay.
The pump too. Right now we're overusing in dissipation and pump size.
And right now, though, unfortunately, because your real equipment didn't get here, you're using some borrowed gear from Texas and from
this actually
Purdue.
didn't even fit. We had to modify this a lot to get it in the tank. This was an inch over, so I'm not sure if they're going to be happy.
We did a lot of modifications actually last night. We had to remove it had an SAS RAID card in here, so we had to pull it out with SATA to be able to use solid states.
Okay. Have to use the solid states. Movable parts are not good.
I also had to modify this. This was one of the ears with the power buttons, and I had to modify it and bring it out back instead of the front.
You guys doing a lot of shade tree work on this. Nice. I like that.
This is what we had to do.
The more you know, the more you can do simple fabrication, sadly.
Yep.
And
got
we
the
also
surgical tools on top there you were using.
Yeah.
We did a lot of surgery to this last night.
That's what I used to modify the power supply fans.
So you guys happy with this now you got it together? I mean, you're going to be in the game.
Yeah, at least we're happy enough to get the
We're
parts
going to be able
equipment.
to demonstrate what we would have brought with our server because we had some compilation issues with the AMD. But we will be able to demonstrate what we were bringing.
At least on this one node, on the R720, because this was our original setup that we were going to have all
Exactly, that we managed to borrow from UT.
Okay.
That was their only stipulation. You can't dunk these.
No dunking. Yeah.
Exactly.
Yeah, they've been down that road.
Yeah. Ours wasn't as bad.
They didn't bring it back, but
the other thing that we had to do was pressure fit this with the styrofoam.
You need a pressure differential from the top to the bottom. Because go ahead.
We're pumping backwards, so we're pumping in on the bottom and
pushing
out the top.
Pushing up and off the bottom.
The reason why we did that was to get any free convection that could possibly have helped us. We were utilizing.
And it's also a little bit like electricity, where if you don't have any resistance in the circuit, so if we didn't have these right here, the liquid would have flowed the easiest way and it wouldn't have flowed through here.
Okay.
So you have to push it through here. You have to get a tight flow, yes.
Exactly. So with the exact sizing of our tank, I mean, was for 4 nodes, so we had to...
We went to Home Depot last night and did a lot of, like you said.
The only way it would have made it perfect for Texas Tech is if you'd gone to the Walmart.
Hey, we thought about that.
Well, good job, guys. We'll be checking in with you. This is great work.
Appreciate it. Appreciate it.